The standard market assumption is straightforward. When the price of a good rises, producers will naturally want to supply more of it to maximize their profits. But we have to consider the practical reality. If the market price for a sophisticated product spikes tomorrow, can a business actually double its production overnight? Mark Twain famously offered the advice, "Buy land, they're not making it anymore." He was pointing out a physical truth. Certain resources are finite and cannot be manufactured, no matter how high the price goes. This creates a stark contrast between rigid goods like beachfront property and flexible goods like books or cars. In a factory setting, managers can respond to higher prices by simply running longer shifts or adding overtime. Economists measure this difference using price elasticity of supply. This metric tracks exactly how much the quantity supplied changes in response to a shift in price. This flexibility isn't arbitrary. It's governed by the physical nature of the production process. Some goods require specialized raw materials or complex assembly that are difficult to ramp up quickly. The other major factor is time. In the short run, a company is constrained by its existing factory size. You can't fit more machines into a building that is already full. However, in the long run, those physical walls disappear. Given enough years, companies can build entirely new facilities from the ground up, and new competitors can enter the market to meet the demand. Because of this ability to expand total industry capacity over time, long-run supply is significantly more responsive to price changes than what we see in the short term. Time eventually dissolves these physical constraints, allowing the market's response to catch up with a sudden price hike. To visualize these physical limits, economists translate manufacturing flexibility into 5 specific geometric shapes on a graph. This chart illustrates the spectrum of supply. In graph A, we see perfectly inelastic supply. The line is completely vertical, meaning the quantity stays exactly the same regardless of how high the price climbs. As goods become more flexible, the curve tilts. In graph B, an inelastic supply curve remains steep, while graph C shows a unit elastic diagonal, where supply and price move in perfect lockstep. When producers are highly responsive, we see the flatter line of elastic supply in graph D. Here, a small increase in price triggers a large jump in the quantity produced. Graph E shows the theoretical limit, perfectly elastic supply. This horizontal line indicates a situation where producers would provide an infinite amount at a specific price, but nothing at all if the price drops even slightly. The visual rule is simple. The flatter the supply curve, the more physical flexibility and time the producer has to react to the market. It's easy to think of a product having one fixed elasticity number, but production is rarely that consistent. What happens when a factory actually approaches its absolute maximum capacity? When a factory has idle machines and workers, increasing production is easy and inexpensive. In this zone, the supply curve is flat and highly elastic. But the situation shifts once those machines are running 24 hours a day. With no room left to grow, the supply curve bends sharply upward, becoming nearly vertical as it hits the capacity limit. To squeeze out even one more unit at this point, the company would have to build a whole new factory. That massive investment requires an enormous jump in market price just to justify the cost. The supply curve maps the physical friction of the real world, the mounting costs and hard limits that producers face in the pursuit of scale.